In this module, we are going to go over the different ways that we can get data from a file on a computer system and write file data to the file systems. So for the most part, file input-output in Python is very easy. We first create a file object with the open function in this manner, where open is a function and what it's going to return is a file object that we're going to assign to some particular variable. In this case, I'm calling it file object. We pass it a string that is pointing to where the file we want to read or write is located, and we pass it an argument that tells it whether we want to read from an existing file, write to a file, or append to a file. And there are other options like binary, and that depends on how we want to, whether we want to write in like a plain text format or a binary format. I should say that if we provide the W option for opening up a file for write, if that file already exists, it will be erased by the write command. Okay, so here I have my test file.txt. I'm going to create a string that will include the directory to the directory path to the data dir that's stored in data dir that I've defined, and I'm opening it to write. And in this case, I'm going to list the directory contents and see if that file exists. And if we do that, we get true. And just to show that if I change my test name to 3, so I have a new file, that's created and listed out, and we can print the directory files. So those are the files that are there. If I create a new file and run this, you see that that's added to the files in the directory. So once we have this file object open, what are we going to do with it? Well, if we have opened it for read, then there's 3 basic functions that we can look at. The first is read, where it takes an optional argument of number of bytes to read in, and it will read from the file until that number of bytes has been acquired. And if we don't provide any bytes, it will read the entire file, and it will read it into one string. Another function is read line. So this will read the next line in the file, and it's basically relying on the file system to be able, the program to be able to identify line breaks in the file. The third one is read lines, which reads all the lines that are contained in the file into a list of strings. So each line in the file is represented as a string, and then the collection of those strings in the list represents the file that was opened. Okay, similarly we can write, and this takes as an argument a string to be written and write lines, where I take an iterable object to a file. So I might have a list of strings that I'm going to write out. And kind of as a note on these write, I think I say this later, when I write a string out, it does not automatically add a new line character. So if I'm looping through something and I'm writing a line at a time, if I don't explicitly put a new line character into the write statement, all those lines will be conflated into one line in the file. Okay, so an example. So I've put up into the Canvas website a file icd9short.txt, and I've put it in my data dir directory, and so I'm going to open it up to read. And let's evaluate this. Okay, so I opened up the file, so I have this file object f, and I'm going to iterate over that file, and this iteration allows me to do a line at a time, and then I'm going to print the line. Now, this doesn't look like the file that I expected on disk. So let's see. If I add in well, let's just see what I got here. And essentially what's happening here is I am having problems recognizing the line breaks in the file. So here I'm going to use the seek function, and the seek function tells me to take that file object and return its location to where it's queued up to read the next bit of data from, back to 0-byte offset, so right at the beginning of the file. And now I'm going to try to read the lines in the file. And when I do this, I see that I do have a list, but it's only of length 1. So what's going on here? So Python on my Mac is having a hard time recognizing line breaks that were generated from a Windows file. And so one thing I can do is I can explicitly go into that line that I read and use a split where I just happen to know that this -r is the line separator that's in the file. And now, after I've split that single line up on this -r character, I have 675 lines represented in my list. Well, I can try to avoid that problem by opening the file in what is called universal new line mode. And that's where I have the R followed by this capital U. I'm not positive whether it needs to be a capital U or not, but it works. And so here, we're doing the same thing that we did before. I'm opening the file, although I need to update this. And I'm going to do read lines, then I'm going to print how long it is. So when I just opened it with a regular R mode, I had 1 line in my list. And now as we run this, I have the 675 lines that I'm expecting. So universal new line mode is sometimes needed to properly read in the files. Okay, now I'm going to use the seek command to take me back to the beginning of the file, and I'm going to use the read command. Now in this case, data is a string, and it's one string that represents the entire file content. Okay, another way, so here we are using the open as a single statement where we're assigning it to a variable. Another useful syntax for opening files is to use the with statement. So with the with statement, I can open a file, iterate over it, and automatically close it when I'm done reading or writing. So the syntax here is with the open command. Okay, I'm going to replace that. As f, now this is now the variable that is containing my file object. I'm going to read the lines, and then when I've read the last line in the file, this will break out of the with statement and automatically close the file. And when I look at it, I've now read in the 675 lines that I'm expecting, and if I test to whether f is open or closed, and test to see that it's closed, I get that it returns true, that that file has automatically been closed. Okay, so that's the basic Python read format, where I'm reading in a string, and then if I want to split that string up, say it's a list of it's a comma separated list of numbers on each row, I have to explicitly go in there and do the splitting myself. A convenience function for this is that Python comes with a CSV file format reader. And the only caveat here is in Python 2.7, this module has problems with Unicode. So if you're going to be reading in Unicode data, you need to install the Unicode CSV file, and this is just a straight drop-in replacement for the CSV reader that comes in Python. So let's see how this works. So I'm going to import CSV, and then I'm going to do this with open, provide it the path of where I'm going to be the file I want to open. I'm telling it to read it, open it for read in a universal new line mode. I assign my file object to f, and now I take that file object f and I pass it as an argument to the CSV reader. By default, it's going to use the delimiter as a comment, and in this case I'm telling it to use a tab as the delimiter, and this returns a reader object. And the reader object allows me to iterate over the rows in the file. In this case, I know that I have 20 rows of header information, and so I'm just going to create a header using list comprehension where I'm going to iterate. I'm going to go over 20 times and just read the next row via this reader.next statement. So this reader.next reads in and returns to the calling program the next line in the file. So after I've read the first 20 lines and put them into the header, what I'm now going to do is iterate over the rows that are in the file through the reader object, and I'm going to ask a question. So if in column 2, the third column of the row, if that's equal to yes, then I'm going to append it to data. And what this is, the yes is if this particular ICD-9 code is in the top 100 diagnoses. That's flagged with a yes statement. And so I read my row. The CSV reader automatically splits that row up on the tabs that are in the row, and then I can ask a question about a particular column, in this case column 3. And if I run through this, I'm going to see that I've read in 100 like we expected. We are collecting the top 100 diagnoses. There are 100 of them. And then I'm printing off the information that we skipped over by reading it into the header. Okay, so that was reading in. We can also use file objects to write out strings. Any other object that I want to write to file must first be converted to a string. And as I mentioned earlier, write does not add line breaks. So if I want to have distinct lines in my output, I have to explicitly add the line breaks to the write statement. Okay, so here I'm opening up a file. In this case, I'm opening it up in a write mode. And I'm going to write out a string. This is the first line in my file. And then I'm going to write out another string. This will also be on my first line of the file because I didn't add a line break to the first statement, but I did here. And then I'm going to write out the number 5 on 2 different lines and close the file. And then what we can do here is we can just open a new, we can do this while with open my test file.text as f. We can do message equals f.read, and then we can print message. You see, this is just the behavior that I described. Okay, Python also includes functions for letting us read content over the web as if they were files. And so there's 2 different modules. I don't exactly know why there's urllib and urllib2. But the urllib2 has a URL open, which creates a file-like object for reading web content, and urllib has a URL retrieve, which allows us to download and store as a local file the web content that we're pointing to. So an example here, I'm going to import urllib2. I'm going to connect to the python.org website. I'm going to read the contents of that website into Python text, and I'm just going to print the first 200 characters of that. You can see here we're just getting the basic HTML definition of that page. If we go down a little, we can go somewhere else. Put that in there. and still getting a lot of just header information that we've read from that website. Okay, here we're using the URL retrieve, where I'm passing it a website that I want to read from, a file name that I'm going to write to, and what the content that's returned. In this case, it's returning that I wrote out an HTTP message to python temp.txt. Python also has libraries for letting us read from compressed files. So the gzip library allows me to open a compressed file as if it were a normal file, and then I can read and write the same as the regular open command. So here's an example of code that I've written for my own image analysis, where I've taken some graph structures that represent the topology of a vascular circulation system. And originally I didn't write it out in a zipped format, and then I started writing out in a zipped format to save disk space. And so what I do here is I first try to open it up as a zip file, and then use a pickle to load it up. If I try to open it up as a zip file and it's not a zip file, it'll throw an exception, and so then I go and I try to open it in a normal way and read it and return the data. It's often tedious to convert everything that you want to write to disk to a string, and so there are various ways that Pickle can help you. So if I'm only worried about reading and writing out data that will then be read by another Python program, I can use Pickle. There are some limits to what can be pickled, and I have a comment here that there's some security issues with it. And we've played around with Pickle, or at least we've talked about pickles before. There's also the JSON package that allows us to write out objects in the JavaScript object notation format. And this has become probably the most common data exchange format. It's more limited in what can be serialized than the pickle file. And serialized is just a fancy way of saying that we're taking this object in our Python function and writing it out to file. And so there's JSON dumps, which serializes to a string, JSON dump, which serializes to a file, and JSON load, which deserializes from a file. We'll cover this more, and we've already played around with the some, but there are different packages for reading and writing images. Kind of the old, it hasn't been updated in a while, but still standard way of reading in images like TIFFs and JPEGs and PNGs is the Python imaging library, PIL. Image is outdated, and I believe it's been replaced by a package called Willow. SimpleITK is a medical image-oriented package that has functionality for reading, writing, and manipulating n-dimensional images. It also includes segmentation algorithms. And SciPy includes, and we don't need to install SciPy because it comes with Anaconda, has libraries for reading and writing images. And let's see if I can make this work. This is just demonstrating reading in a photograph. So here's a sunset off of Antelope Island in the snow when I was riding my fat bike. I pass it the file location, and IMRead returns the image as a NumPy array. And if I print out, let me just add here, image shape, then you see we have a 2448, 3264 by 3, and this is the red, green, and blue channels for the Z dimensions.